Here in probably the next 30 or 40 feet, we're going to try to answer a lot of questions. So if you pull out your little page there, the morphology, the little diagram they show in there, this is kind of on these massive concretions, commonly what you see in the field. So you'll have, as we've seen, kind of shale wrapped around them, this massive outer core, and this inner core, which a lot of these, once they've been weathered, kind of come out. And when we get down a concretion or two, we'll talk about the mineralogical changes from outer to inner when we get a couple of them down. It's kind of hard to see here, but we'll see down a little bit. Is the grain size in these things change also. We'll see kind of massive calcite crystals in the cores of these things, and they get finer and finer to the outside. And what we generally see in all of these, if you guys, this one's probably, there's 3 feet. This one's 5 or 6 feet across. So the bigger these things get, usually also, the more oblate they start to get. So that's one thing that we'll talk about is, why are some of these things so spherical, and then some of them, in particular the big ones in the lower Huron, get really flattened out. So when you've got, again, like I was saying before, you've got a pair. Now what's interesting is this guy, that one's totally eroded out. And then this one has the inside still completely intact. So, these concretions are all very different. And that's what some of the researchers, and that's what's caused different people to think different ways with them. There's some common processes here, but the morphology of all things is kind of pretty complex.
John, at the time of deposition, when these concretions started, do you think they were pretty close to the ocean floor or buried at a greater depth?
So let's look right now at potentially that.
Okay.
So now we're looking at a cross section in this guy, and this is one I just saw this morning because the creek's really down. And this is another common relationship is you've got an outer, in the biggest concretions, you generally got an outer core, then you'll see striated mineral development. But I think what's most fascinating about this one, and it may answer some of our questions, is these markings in here. What do these look like to you guys? We'll try to get the nose right up on these things. And take a look at them. Somebody throw out a guess. So biological activity, and what we'll see in some of the shale over here, and what I think we see smack in the center of this concretion is a plane, a bedding plane that has trace fossils on it. With all these little, you won't see them better over here, these little things here. Well, some of them on the edge here are kind of oriented, so to me those are kind of questionable, but a lot of these guys look identical to the trace fossils we'll see in the shale down here. So that relationship, that the bedding was present and that these concretions potentially grew in the bedding, we'll see in full detail in the next one. But to me, one of the biggest, the greatest lines of evidence is these trace fossils in a plane going straight through this concretion. So you can imagine, and that's one of the parts I guess we fill in now. So at the center of a percentage of these, not a massive percentage, but 5 or 10% of these, there are either arthrodire fossils or plant material. So in some of the best examples, and if you, the Cook, Chris, and Day paper, they've got a picture of it, just a beautiful arthrodire jawbone smack in the center of this, and the concretion develops out. So, what we do know, and we don't see that in any of these trace fossils are the only biological evidence we see in outcrop. Is generally there's a nucleus to these things, and they build out from there rather rapidly.
For the see example, the geosurvey at our coral lab at Allen Creek, we've got a concretion there, and there's a nice jawbone in one of the arthrodires, and that there on display there. You can see that up there.
So one of the things that we don't see in outcrop, what is published is, within these concretions there are microfossils, algal fossils, tasmanids, and things. And within the concretions, they're three-dimensional and non-crushed. And those same fossils, when we get into the shale, are all laminar crushed. So what that tells us, when we look at these trace fossils, and that's one of the lines of evidence that we can't see in outcrop is, there were things that happened very rapidly that cemented these concretions in place relatively in their form, and then the shales potentially would form after those concretions had their shape. Now their mineralogy has changed, and we'll talk about that a couple down, but their general shape was formed very early. So everybody who hasn't had a chance or wants to get their feet wet, kind of come down to the other thing you can see the edges of the shale wrapping around this, but these, you guys tell me whether you think these look like the trace fossils once we get down here or not.